Hi everyone, welcome to a new video. In this video, we'll learn about a shortcut to compute a 3x3 determinant. So let me show you this shortcut. Let's say we want to compute the following 3x3 determinant. So the first thing to compute this determinant is to copy the first two columns to the right of the determinant. So let me write the first column to the right. So we have 1, 3, minus 1. And then we copy the second column, will be 2, 4, 5. And in order to compute the determinant, we need to form the product of the element of 6 diagonals. And 3 of these diagonals will have a positive sign and 3 will have a negative sign. So let's start first with the positive diagonals. So these diagonals, you form them using the original first row. You start with the first element in the original row and then you move diagonally. So this gives us the first diagonal that is positive. Notice that by diagonal mean that you are moving to the element below the current element and to the right. So the first element here is 1. The element below it is 3, but you don't go to 3, go to the 1 to the right of 3. The second element is 4. So the next element to go to is the 1 to the right in the row below. The one below 4 is 5, so the one to its right is 4. So this is the first diagonal. Second diagonal, you can form it also similarly, but you start with the second element in the first row. So the second element is 2, we again move diagonally. Mean you are going to the element to the right in the row below it, and similarly to the element in the row below it. So this is also a positive diagonal. The last positive diagonal is the one also starting with the third element in the first row. So again, moving diagonally. Again, diagonally mean you go to the element to the right in the row below it. So minus 6 below it 1, just go to the one to the right, which is 3. 3 below it minus 1, go to the element to the right, which is 5. So this gives us first 3 diagonals. Now we need also to form another 3 that will have a negative sign. So these you form them by starting with the third row in the original determinant. So we take the first element in the third row and we move diagonally up. So diagonally up this way. So this is similar to the positive diagonal, but except that you are moving up. So the first element is minus 1. The one above it is 3, but you go to the element to the right, which is 4. Similarly, 4 above it 2, you want the element to its right, which is minus 6. So this will have a negative sign when we are doing the calculation. Then you start with the second element in the third row. And again, we draw a diagonal. Similarly, we go to the third element in the third row and we move diagonal. So now we have these 3 diagonals. What we need now to do to compute the determinant is simply to get the product of each of these diagonal and then adding sign according to whether this is the positive diagonal or a negative diagonal. So then the determinant will equal to, we'll multiply the first positive diagonal, so 1 times 4 times 4 give us 16, and the sign for this is positive, so it remains positive. The second positive diagonal, multiply the element, 2 times 1 times minus 1, this gives us minus 2, and the sign is positive, so mean that the sign of the product will not change, so it will be minus 2. And then the third positive diagonal, minus 6 times 3 times 5. This will give us minus 90. Then we go to the negative diagonals. So we multiply the element in the first negative diagonal, minus 1 times 4 times minus 6. This gives us positive 24. But the sign here is negative for this diagonal, so we have to add a sign, so it becomes minus 24. The second negative diagonal is 5 times 1 times 1 give us 5. And then again, we need to add the negative signs to the product, so get minus 5. And then the third negative diagonal, 4 times 3 times 2, this gives us 24. And again, we need to add a minus sign, so it will become minus 24. Now we simply add all of these. You will get minus 129, and that's the value of the determinant. You can, of course, double check this by using, for example, the cofactorial expansion. And if you're not familiar with that, you can check the channel. There is a video that explains that method. Let me show you another example. Okay, so this is our second example. So again, we do the same thing. We need to copy first the first 2 columns to the right. So minus 1, 3, 5. And the second column will be 2, 4, and 1. Now again, we form the positive diagonals. We start with the first row, start with the first element and move diagonally. This will be a positive diagonal. Start with the second element in the first row, move diagonally. Positive also sign. Third element in the first row and move diagonally. And then we form the negative diagonals. So starting in the third row this time, the first element, and move diagonally up. Second element, and then also move diagonally up. Third element, and move diagonally up, and also negative. Again, the calculation is simply you multiply the elements in each of these diagonal and you add the sign according to whether it's a positive diagonal or a negative diagonal. So we'll start with the first positive diagonal. Minus 1 times 4 times 7 give us minus 28, and because the diagonal sign is positive, meaning that the sign will not change, it will remain minus 28. Then the second diagonal, 2 times 5, this give us 20, and again sign does not change because this is a positive diagonal. Then the third positive diagonal, 1 times 3 times 1, this gives us positive 3. Now we move to the negative diagonals. So the first one is 5 times 4 times 1 give us 20. Now this is the value of the product, but this is a negative diagonal, so we need to add a negative sign. So we get minus 20. The second negative diagonal, 1 times 2 times minus 1 give us minus 2, but then again also need to add a minus. So minus with a minus give you plus, so you get plus 2. 7 times 3 times 2, this gives us 42. And then again, we need to add a negative sign to it. So we get minus 42. If you calculate all of this, you'll get minus 65. So that's the value of the determinant. So this shortcut works for 3 by 3. Don't apply it to other larger size. Finally, if you find this video useful, please give it a like and consider subscribing to the channel and turn the notification on so that you get notified about new content. Thank you for watching.